using the same code to get varying behaviors with different reward weights here on Machine Learning Basics. Hey everybody, Blake here, and we have an example of two drones, and these are the same drones that we had last video, except that we're getting some very different behaviors out of them. And in this case, the core of the behavior that's running both of these drones is the same. They're actually using the same agent script. I have different brains on them with different neural nets, so they've been trained in different ways with different parameters. In this case, I left the hyperparameters out of it, tried to do all of the training with the same hyperparameters, and so this is just some of the differing behaviors that you can get by altering the actual drone agent parameters when you're doing the training. And so you can get a bunch of really cool different behaviors. So I'm going to stop this, and I will show you the project here. Okay, and great. Let me make this a little bigger. Perfect. Okay, so this is just in a demo scene, so I'll go to, well, actually I have another demo scene set up. So I'm showing two drones there, and this is with everything made pretty so that it makes, you know, a nice little video. But we have another one. Oh yes, I do want to save that. All right, and so we have our drones here. So these are the same ones. So I didn't train 2, I trained 5 of them, and they all have some different behaviors, and there's a reason why I have another demo scene. So I will go ahead, yeah, I'll just leave that there. Okay, so we'll go ahead and hit play, and we'll see some of these behaviors. Okay, so that one's doing this crazy Fruit Loopy thing. Right, that one seems pretty stable, and you know, we talked about the last video. Maybe we want to try to make it more stable, and that's what we did here. That one just flew off who knows where. This one is right down there. It's extremely stable. It's just on the floor. And then that one doesn't look so bad either. Now, I will say, some of these are very interesting. I'm going to go through the training process and kind of what I have. I'm going to go from the other angle just so we can see it again. I'm going to fire it up. Keep your eye on number 3 here in the middle, because it starts off and then there it goes. Goodbye. Goodbye, number 3, wherever you are. Right, and number 4 just crashed, and number 5 seems to be fine. So this one is clearly very different. It's kind of Fruit Loopy, and if I move its destination, you'll see it moving around a bit, but it follows it-ish and tries to stay fairly close. This one, number 2 here, let's see here, I'll move the destination, right? I can move that around, and it's super duper flat, but also kind of slow, and that's actually why I didn't stop with that one. We'll talk about why that behavior is the way it is, but it's, you know, extremely flat. It does a great job on staying level, but it's also really slow. And then 3 just went off to nowhere, 4 crashed, and then 5, oh, grabbed the destination right off the bat that time, right? Seems to move around fairly well, pretty stable. And this one actually moves a bit faster than 2 does, although I haven't had races. Maybe I should have a race between them, but it's pretty good. And then it gets a little wobbly when it's actually on the marker, and that's because it's less sure what to do when it's sitting right on the marker, because most of its possible inputs are all equally valid, and so you get a little bit more randomization there when it's on the target. But, you know, overall not bad, especially if you keep the target moving. It looks really nice. If it is able to actually reach the target and sit there, then it, you know, gets a little bouncier. But that's also not the end of the world either. You know, it looks a little turbulent. So none of these are necessarily bad. Like this one over here, number 1 on the right, looks pretty cool, even though it's I mean, completely unrealistic for a quad rotor, but it's, you know, it's got this weird flippy thing, and it does follow destinations fine. Like, it will chase down the destination and do its best to actually get somewhere. It just does it in this crazy loopy way. So what's going on with these folks? Well, so here's our drone, and I have two different metrics. Now, the first thing that you might notice if you've seen some of these videos before is my starting height, minimum, maximum are both 0. So this is a randomization that I put in there so that when I'm training them, that the destination where they're trying to go is above or below the starting point. In this case, both of those are 0 just for the purposes of the demo, because I wanted all of the destinations to start at the level where setting up the demo, so they weren't randomly going up and down for the purposes of demos. So normally those are 2 and -2. So grace distance, so that is how far do you have to be from the destination target in order to collect the on-target reward, right? The bigger that is, the larger the area where that kind of random behavior is. The smaller it is, the harder it is for the drone to actually stay on it and consider itself okay. So this is certainly something you gotta play with a little bit. In this case, I just made it the same size as a cube. 0.1 seemed to work. Up force, this is, these are modeled using Unity's physics, so they do actually have 4 thrusters, and so that is the maximum amount of force. Basically with the 4 thrusters, they can go up or down, right? So -1 to 1, and so I just multiply that, and it's a scale. So they each get 10 units of force. Now, reward scale, this is how much they get for being on the point, as determined by the grace distance. The energy reward scale, so this is how much are they given or removed, or how much value is given to them or removed as part of the reward based on their energy usage. And that's one of the parameters we'll talk about here in a little bit. Minimum height, so that's to help try to keep them from crashing. Minimum height reward, so if they are below the minimum height, this is a penalty. On target reward, it's 0.2, which, yeah, so that and reward scale, I actually have to take a look at those two, because I'm wondering if reward scale is deprecated and no longer used, actually. Flat degree grace, so this is where I start talking about how flat do you want to be, that if you're tilted maybe a couple degrees, you say, it's flat enough to call it flat, you get the reward. But if you're tilted further than that, or I'm sorry, yeah, you're saved from a penalty, right? But then if you're off flat, then we take the number of degrees and then we penalize you. And in this case, a penalization is very small, negative 0.001. So that's the penalty. So if you're too far off, then we take the angle that you are off and then multiply it by that reward. And that is the penalty for that. So if we look at the actual reward function, so we have, again, improvement. So this is anytime that we're doing this kind of training, how are we rewarding it? We are rewarding it for getting better, for getting closer, right? So, okay, yeah, so that is the reward scale times the improvement, right? So how much do we reward it for the improvement? So right now we're just saying 1 to 1, whatever the improvement is, that's the base reward that we're giving. From there, we add the energy portion, right? And so this energy portion is how much energy have you used, and so that's a max of the 4 thrusters. The highest one, that is the most energy you've used, and so that gets multiplied by the energy reward scale. The height portion, again, if you are under the minimum height, then you get a penalty, and so that's what that's about. And then the on-target reward, you get a bonus, so you get points for getting closer and closer and closer, and then you get a bonus for actually being on target. And then angle portion, that's, again, you get a penalty if you are too far up, right? So here's the angle of error, right? And then if the angle of error, right, is negative, then we take it to 0 because we take the angle of error, which is always a positive number, and then we subtract the grace amount. And so if that is negative, that means that you're within the grace zone, and so we just set the angle portion to 0, and then we multiply it by the off flat reward, which in this case is a negative number, which means it's penalty. So in this case, I have phrased everything as rewards, even though some of them are negative, but what it does is it keeps the math consistent so that I can just return this, this plus this plus this plus this plus this, instead of worrying about adding some and subtracting other ones. It just helps keep everything simple. So no, this is not this reward scale, this is the improvement reward. So that is still valid. So all 5 of these have used different variations of these reward parameters, right? So I've adjusted these reward parameters, and then I trained them, and I got these different behaviors. So what the heck did I do for each of these to get such different behaviors? Well, so the first one that was doing that crazy looping thing, and I'll pull up the training for it, was pretty simple, actually. I turned off the energy completely, and I said, I'm not worried about how much energy you expend, I just want you within 0.1 of your destination. And so that's why it has such this crazy loopy behavior, is because it doesn't care about how much energy it uses, and so being unstable means that it can move from one place to another fairly rapidly, and it seems to have found that as an optimization, so that's kind of cool. For the second one, what I did is I said, all right, I'm going to bring energy back in, and I also bumped up the reward for being flat. Right, and so I think it was negative 0.4, and that was actually a very strong signal. So we see that here that it starts off very low, very, very low, and then it rapidly improves here. I'll even turn off smoothing entirely because these graphs are beautiful. And so it improved very quickly, and what's interesting is over here it actually got better than the one with the no energy cost, right? Because what happens is the one that doesn't have an energy cost, because it is so unstable, it has not learned to stay right on that target, and so it goes off a little bit, so its reward never goes quite as high. And so, it learns that that's the best thing for it, but really it could be optimized a little bit better with a different approach. And so this one, is trying to be flat, and it had a very, very strong, hey, stay flat signal. And in many ways it was too strong, because that's what's actually causing it to move so slowly, because it's so concerned about being flat that it's not willing to tilt so that it can move forward. It wants to really stay flat. And so it learned to really stay flat, and it did pretty good, but it was actually too slow for a lot of the things that I wanted to use it for, so I needed it to be comfortable with being a little less stable. So that's where we cared about the energy usage and flatness. Now 3 is this really interesting case, because it does this thing and then it just drifts off into nowhere. And the truth of the matter is, I wish I had an explanation. I knew I was in trouble, or I knew something weird was going to happen as soon as I looked at the chart for this, because I have no explanation for what the heck happened. It starts off and it goes fine and it got great, and then drops like a stone, and then takes this huge amount of time to recover, like a 250,000 iterations to recover. So first 250,000 goes here, and then it drops, and then it has this other 250,000, and then eventually comes up, but is kind of garbage, especially compared to the other two. And so that isn't super great, and it had this strange behavior. I have no idea why it did this. I have absolutely no idea why. So I said, you know what, I'm going to run it again. I'm going to scale back, and this is each of these. I'm scaling it back a little bit. And so I said, you know what, I'm going to scale back the off flat signal a little bit because I think it's too strong, and that might be part of it, right? So I scaled back the off flat penalty, and so that means that the initial scores start higher, right? And that's just because the amount of time that it's spending with that off flat is smaller. But as we see, it goes up, and we still get this strange behavior, and this is the one that just went down and crashed, and so it stays flat, and both of them do stay flat, but they acted really weird, and I still don't know why I did it, and I knew I was having some strange behavior, so I just restarted my machine. That was my solution for it, was just a good old-fashioned reboot. And then I also said, you know what, this still seems a little heavy-handed in terms of the, hey, stay flat kind of reward, and so that's when I did the fifth one. And so you'll see that it starts off much lower, and actually let me go ahead and just pick this up by itself. There we go. You can hear my dog, he's being silly. You are a silly dog, Watson. And you can see in the first 100,000 iterations, or just over, it basically trained. And it took the rest of the million iterations, and it was... What are you doing, silly dog? And the rest of the million iterations, it was just optimizing. And that's what it did the entire time. So, there we go. That's basically what I've been doing, and I think it turned out great. Again, all of these will be uploaded, and you can see these different brains. And yeah, the big solution to that, hey, what the heck happened in 3 was, I don't know, I rebooted my machine and then it seemed to work again. And again, I toned down the off-flat reward, and so it quickly learns, oh yeah, okay, I can, be off-flat and then learn a bunch of stuff, and it learns to be really flat, and so it's nice and stable, and it does what it needs to do. So there we are. If you have any questions, please feel free to reach out to me. You can reach me on YouTube or on Patreon. If you are interested in being a patron, if you're getting value out of a bunch of these, then please feel free to check it out. If you're not ready to do that, but you still feel like you're getting some value out of these videos, please go ahead and like and subscribe to the channel. I'm always happy to have people on and share projects, see what folks are up to, and answer questions. I just thought this was kind of cool, a nice set of results of how different behaviors you can get just by adjusting some of these parameters. So I know that this version of ML Agents is a little on the old side, so I'm going to be updating both my Unity version and my ML Agent stuff. They have some new releases that are pretty cool. I think there's some nice features coming out, so I'm going to cover some of those cool new features, because some of it is stuff that we've wished about. In the meantime, go play with this silly dog. And I hope you all have a great time. Take care, good luck, and happy learning.